Let's start again. Welcome. So today we're going to take a look at values in Java, which are a foundational concept representing quantities that are computed in a model, such as numbers or references to people. We're going to look at expressions, which basically compute values, which calculate values, as it were, and variables that can hold values. But which can hold different values over time. Okay. A value is a single quantity, cannot be further evaluated. So it might be an integer, 2, 5, 6. It might be a floating point value, 2.3, 3.14, 2.71, 1.0. It could be characters like A, B, etc. Could be a Boolean, true or false, or it could be something that involves a little bit more conceptualization. It could be a reference to an object. And this object that it refers to could be, for example, a person, an instance of a person, so some particular person. It could be a string, like a quoted string that says, ABM, and you put quotes around it. It's a reference to that. It could be to the main, like when in any logic, when we have person, I'll go open this, but when we have person, we have a reference already to main because if this person is embedded in main. So if we were to go look at person here, we notice there's a reference up here to main. It allows us to say main dot whatever. It could be a reference, in short, to many different types of things. So these are values. Values are used, they're printed out, they're stored away in a spreadsheet, they are set to be the value of some variable or what have you. They're very basic sort of atoms of computation. We could take two values and add them together, for example. In order to do that, we make use of what's called, confusingly by computer scientists, an expression. An expression is something you might call informally a formula, or you might call it a sort of a calculation. Okay, so an expression might be like A plus B. That's an expression. A and B, like maybe it's 2.0 plus 3.14. Each of those is a value. The expression is, the sum of those two. Or an expression might be something like A equals B, testing whether this is equal, or A times B. We've seen this before. Where have we seen this sort of expression? Does anyone remember that? We saw it at several junctures. Sorry? For color, exactly, for color. So we tested if this person is male. If so, we used one color, otherwise the other. Or just if they're female, make it yellow, otherwise gray. We tested are they in a certain state. If so, like a state of chronic heart disease. If so, we will color it red on the outside. Otherwise, we'll color it black or whatever. Right? So this is like an if-else expression. We don't say statement because this is not a statement. A statement has commands to do something if it is true or it's not. This is, like all expressions, this returns a value. It gives you a number of one of these quantities, one of these guys. Okay, these kind of atoms. So a job of an expression in life is to serve as a formula that calculates values. Now, expressions come in many sorts, and it's useful to recognize some common ones that are not immediately obvious. This tests equality. Are A and B equal? This test is A less than or equal to B. We don't have a really nice way of writing it with sort of the expression we'll use in class. So we write it this way. Okay, it looks like an arrow, but it's actually a less than or equal to. This tests if A is not equal to B. Okay, and in general, this not can be used for computation on what are called Booleans, to take the not of something. So we could say, is A equal B, and we could take the not of it with a exclamation point. So if it was true, it's now false, or if it was false, it's now true. Now, with these expressions, there's a little bit more sophistication for some of them. For example, there are some expressions that compute, and an expression by definition computes a value. It computes one of these kind of atoms of information, these sort of quantities that are computed, let's say a number or a reference to a string. But it can also do other things in the process. So one thing you can get as an expression is something like A equals B. This actually assigns to, meaning it makes A store whatever value is in B. After this, A will contain a value that's the same as the value that was in B, and that remains in B. Turns out this does something, but it also computes. It gives you that value, whatever it is that was in B, that's what it gives you as a result. And perhaps even more confusingly, and I don't suggest taking advantage of these as expressions, you can have things like this, A++, which confusingly is a little bit different from ++A. A++ gives you the value of A and then changes A to be one bigger than its value. So it actually gives you the old value of A and makes it one bigger. This one makes A one larger and then gives you the resulting value. This adds 2 to A and gives you the resulting value. This multiplies A by 5 and gives you the resulting values. I don't view it as good code style, and others join me in this, to write these in the middle of an expression. Like I wouldn't want to write B times A++, but there are people out there who do that. I just don't recommend it. I never use these except on their own line or in very specific things like a for loop. Okay, so you have to be cautious about when using this. But another type of expression that we see a lot is something we saw all through today. Let's go take a look at it. Where would we have seen this? Basically, it's something where there's an expression where we set people's, let's go to main, where we set people's age. We certainly saw this a lot, even in the very first model, population heterogeneity, where to set someone's age here, we drew it from a distribution. Remember that? Or here's an expression where it calls off to sample a value from a log normal. This gives us back a value. It gives you back a number drawn from this distribution. But it's a function call. It's actually calling, give me a value. And many a time have we written an expression like, for the location, right? Uniform of this. This is an expression. Why is it an expression? Because its job in life is to give you a value back. It's a formula for a value. But in the process of computing that value, it calls off to this function called uniform, which does who knows what. Maybe it has lots of statements in it. But ultimately, it gives you back a value. So Java expressions can be very simple, like 3.2. It could be more complicated, like 3.2 plus 2, as the sum of those two. It could be more complicated yet, involving what's called ternary operator, tests a predicate and uses one or the other. Or it could even involve a function call. Now, more common expressions include these. Here's a logical not, so it takes the not of this. Is this true and this is true? Like, is this a male and they are between the age of 10 and 10 and 20 or something like that, is x above 0 and less than or equal to 500. Okay, that's what this is. It's a logical and. You may wonder, why do you need two of them? Well, there's another one that only has one. That's for what's called bitwise and, when you're dealing with ones and zeros at the very basic level. You don't want to typically use that. So this is or. This or that is true. Or you could use not. So this is saying if it's not in this range, in other words, if x is outside of the range 0 to 500 inclusive. Okay. For strings, you can concatenate them. We've used this a lot. Do you remember where we used this? Plus. We used it a lot in our model yesterday. What's that?
You were doing your trace.
Yeah, trace ln. Remember when we had a click? Remember when we were clicking on things and it was printing out information? Do you remember that? We actually had it in smoking and heart disease, and it would print out like, I am this, and I can't remember what it said. It's my age is this, my whatever. But it occurred when we clicked on things. So here it was, and it was with heart disease. And when we clicked on this guy here, I think it would print something out. So when we have trace lens, we do this a lot. We say this string plus this string plus this string plus this string, and that's all. That's a big expression. This is what function calls look like. And if there's nothing needed from there, nothing needed to do its job, you don't give it anything. These are called the arguments to the function call, 2 and 3. They're also informally called the parameters for the function call. And if we don't pass, if the function doesn't need any information to do its job, we just call the function like that. And if you go and you look here in yesterday's, was it here? Yes, it was this one. If we go and we look at, in this model, we created a function called current age. This is a function. It doesn't require any information to do its job, and it returns a double. So calling it is a type of expression. It computes a value. Why is it an expression? Because it computes a value. One of these numbers or a reference or what have you. This is another type of expression. This one takes element at index 20 in the array called A. It's kind of like a table, one thing after the other. This is an array. It takes the 21st element because we start at 0. Computer scientists and mathematicians have a long-standing disagreement about what number to start at. And things that are used by mathematicians generally start at 1. R is an example. The first element is at index 1. Computer scientists like to start at index 0. And so index 0 is the first thing. Index 1 is the second thing. Index 2 is the third thing. Index 20 is the 21st thing in there. Okay? Okay. Now, you've seen me do this a lot, and maybe you've been confused about it. So I just want to be clear. Expressions are calculated generally from inside out, left to right. Okay. So here we'll first compute get connected of agent of 3. Like, what's my third connected agent? I'll call the name. Excuse me. So first it's A, and then A's get connected agent of 3. So we'll get the fourth agent to whom A is connected. Fourth because there's 0, 1, 2, 3. And then we'll get their name. And then we'll take the length of their name. Okay? So we write these kind of nested expressions a lot. You saw it today from time to time. You saw it when we were writing expressions that, computed some values. We saw it yesterday when we asked for someone's current age. For example, here, right there. We looked up their mortality rate for someone of this age. This thing's calculated first. It gives us a number. 23.2 years old. And then we call this reference mortality rate by age for 23.2. And that reference mortality rate by age is this thing called a function. It's called a table function, which looks up for 23.2 years old what's the hazard rate that applies. So it looks up in this, 23 is about here, and it figures out what this sort of linear interpolation is for that and returns that value. Okay, so we see these nested uses of these things a lot, where it'll compute one inside of the other, and you just have to read it from inside out. Okay, so there's this one, it gives a number, and then whatever that gave, I'll call this function here with that as the argument. Does that make sense? Okay. Expressions are routinely strung together in this sort of way where one is sort of put after the other, one contains another. Okay. Now today, for those who stayed on for it, we did something that was important. We took an important step. And it was at this point. Here's the GIS clinic model. And I went and I'm remembering exactly where it was here. Do you remember they came under care? And we actually declared, I said we were declaring a variable. See this variable? It's called nearest clinic. What does it mean to declare a variable? Well, and you could be forgiven for treating it most of the time, including this time, like we just create a convenient name, a clear and convenient name for this whatever value was returned here. So we have this value, which is a reference to the nearest clinic. We compute it, and we don't want to compute it every time, so we give it a nice name, nearest clinic. That's that value that was returned there. And then we can move to it, and we can tell that clinic, take us in. Walk in. And walk into that clinic. You can be forgiven for thinking that. That's what it is. And that's not a bad way to think about it at first, for many cases. The problem is that variables are not merely names for things. They actually contain a value. They're a location where a value lives. So it's all fine and good to think of this as a name, but the fact of the matter is, in Java, all variables, all names like that, can actually hold other things as well. They're names for locations. Okay, there's an exception. You can have final things. But I could say here, nearest clinic equals foo, and then use it to mean something else, to hold a different value. So this is basically, nearest clinic is actually a location. It's like a little box where we store a certain value. And every time we use it, we pull the value out and use that. But there's nothing to say that we can't throw out what's in there and put something else in there later. Put something else in the box. And then every time it's asked for, we'll give what's currently in the box. So variables, they kind of name a value. They're kind of a way to get that value, but they can be changed. Now variables are associated with a type. See this type? This is saying this contains a reference to a clinic. That's what that's telling us. This contains something that refers to a clinic. Okay? It's a little bit like, think about your spreadsheet. Think about a spreadsheet. Probably everyone in this room has, at one juncture or another, used a spreadsheet, right? And in spreadsheets, we have values, right? 2.0. Oh, 2.0. Okay, I'm batting 0 for. Okay. 3, 3.14159. Yeah, okay. These are values. They're values there. They can't be further evaluated, right? I could write an expression here. Take a look at this. It's this one plus that one. That's an expression, right? But more deeply, these cells are actually more like variables because this happens to hold this 1 right now, but I could later change it to 2, right? It actually holds a value. It isn't a value. The cell isn't a value. It holds a value. And that over time, that value can change, right? So it is with variables. Variables hold values. They contain values. Just like this thing contains this quantity, okay? And in a spreadsheet, we only have a few sort of things that can be in there. Well, okay, it's not trivial. We could have this in there, right? We could have a date in. Oh, we could have an error. Hey, nice. We could have a date. It doesn't print it all out, but there it is, right? This is a date. It has a certain type that's stored there. Tells sort of from what universe of possibilities can that thing come. Okay? It could even have something like a true or false. Watch this. 2 equals 34. Oh, sorry. This is going to be confusing. 2 equals 34. Okay, false. This is like a Boolean. This is like a variable that holds a Boolean. Okay, now, I have to be sensitive to that because I can't do certain things. Like I can't add, I shouldn't be able to add, and I think it will enforce it. Hey, come on. This thing plus this thing. Oh. Okay. That'd be the devil's work. Don't do that. It's probably treating it as 0. It is treating it as 0. Okay. That's nasty stuff. Don't. Okay, watch this. One thing I certainly shouldn't be able to do is to divide this thing by this, right? How much you want to bet? Okay, yeah, so it says, I don't know what to do. And that's because those are of different types. This one, it actually converted to a number and added it. And guess to what number it converted it? 0. You want to be awful cautious about that. In any logic, things, and in Java, things have defined types. They've defined types of values they can hold. They've defined universes of possibilities they can hold. When we declare a variable, like here, we specify what type of thing we can hold in that variable. What thing can be stored inside that box? Okay? We say this box can only contain a reference to a clinic. You can't put a reference to a person in that box. You can't put a reference to a home in that box. You can't put a reference to workplace in that box. It can only hold a reference to a clinic. Now, as it turns out, it could hold a reference to no clinic, to none at all. This is a reference to a clinic. It's a reference to no clinic. You can have that, and it's called null. Okay. It's like putting down, you have a spreadsheet of HSNs, of health identification card numbers, and you have not available, or you have blank. It's like, okay, this should be an HSN, this should be a healthcare identification number, but it's blank. Okay. And as I said, the value of the variable can change over time. Okay. So here we have a value of a variable that points to main. Okay. We used to do this more. Here's a variable called x and a variable called y, and we make use of them subsequently. Now, when we have variables, we can assign to them. We could say, this clinic, nearest clinic equals a certain clinic. And that's an example of where we assign to something that's a container for values. And we can have that in other cases. We could say, like, this person's income is now twice as big as it used to be, right? Or we could say their age just went up by 1. Or we could say their weight was reduced by 20 kilos. For agents in our model, for example. We can do this. So we'll say, like, this person's ethnicity is a random ethnicity. We did a lot of this, didn't we? Think about it. Think about all these different models where we did something similar. Let's take this one. So we had a color. This is a variable. This is just AnyLogic's nice way of showing a variable. But secretly, that's a variable. There's a variable there. In the background, ladies and gentlemen, that's a Java variable. And it's a variable of one of my favorite colors, magenta. Okay. Okay, so there we are. You could see it says, hey, come on, get back there. I'm just showing you secretly what's there. I actually don't know. I don't look at this often, but I strongly suspect if we went and we poked around, we would find there it is. There it's declared. Color called color. That's a variable. It's just in there as a variable. And because of that, we can do things like assign to color. Okay, where did my nice thing go? Here, I guess it was this guy here. We assign to color, right? This is a variable, and we're assigning to it. So this is a statement, but I would also tell you that this is an expression. It actually returns a number. It returns a value. It returns green, but we just throw it away, and we just only use it as a statement. We put a semicolon and say, this is that. It's assigned to that. Okay. So here we're assigning to a variable. And before our assignment there, that held some color. I don't know what it was. Maybe it was black. And now we've changed it to green. Right? That variable, it's a value. It's like a box. It contains a value. And what is this value contain? Well, it's a special type of, it's a very common type of value that's called a reference. It refers to some color called green here. And it has certain appearance and so on. So this is the color variable, and it assigns that. And when this person goes and becomes a current smoker, my skill in using mice upside down is limited. There we are. When that changes, color is now, as we say, overwritten. It's overwritten to now point to red. Now, I shouldn't have erased this. There's still green there. And there may be other things that point to green from elsewhere. Maybe other people are green. It's not easy sometimes being green. But this one points to red. Okay, it's not like this went away. It's not like that this changed. It's just that this one now points to red. Whatever is in color, my color, is now pointing to red. And when I recover, that will change to magenta or something. I don't know what it is. Magenta. Hey, it's even harder scrolling upside down. Okay. Okay. So that's kind of what's going on. Here's another one. Here we are assigning to a variable. We're overwriting the value of that variable. Whatever was there before, it's gone. We say in computer science, we like to say it's clobbered, or it's overwritten, or blown away. It's another way we say it. It's blown away. Okay. So here, whatever value is there before, it's blown away, and we just put in the new one. Notice there's a semicolon after that because we're using it as a statement. The value. This is an expression. It actually gives a value. We just ignore it because all we're taking advantage of is that it writes to this variable. Okay. I don't know if that makes sense to you, but I've tried to express it. Okay. So variables can be found in many places. Okay. So it turns out that there's several types of variables. Let me just tell you about some. Okay. There's ones that are going to be called formal parameters. Like when we define a function, we can actually give it what are called arguments or formal parameters that are specified to it. So when we run the body of the function, it will actually use those. So we pass it some information to do its job at X and a Y location. And it says, yes, ma'am, I will do this with X and Y. I will put a circle with a smiley face at that location. So that's a type of variable, X and Y. And those disappear as soon as the function is gone. Disappeared, gone, blown away. As soon as the function returns, it's gone. So, for example, when we call uniform up here, we pass it some values, and it takes this in with some variable, and it uses it while it's running, and when it returns a value to us, it's gone. Those are no longer relevant. Okay. It's kind of like if I called Cheryl, while we're on the phone, my number is displayed in our caller ID. And when I hang up, that's gone. Boom. Boom, gone. Okay. Not a perfect analogy, but it's okay. Secondly, there are these variables inside of people or other objects like main that we can keep around. And we saw some of them here, right? Here we go. Here's a variable. Here's a variable inside of here. Those are specific to the particular person. So a particular person has a certain color right now. A particular person has a certain hazard rate for developing heart disease right now based on their risk factors. Does that make sense? So these are limited to a specific person. When we have a particular person, it's different. The value of those can be different from this other person and this other one. Each person in the population has a different value for those variables and, in fact, a different birth time. Does that make sense? Hearing no objections. Okay. But then there's another type, too, which we've seen. We've seen several times. And I engage in a combination of explanation and mumbling behavior about it. Kind of hand-waving, but also trying to provide some understanding. That's what's called a class variable. Or a static variable. Horrible. And the place we've seen this is for things like where here we go. So in main, we defined do you remember this? We defined a statistic. Do you remember that? This heart disease is what's called a class variable. It doesn't exist for every single person differently. There's only one value of it for all people. The name of, it's sort of the designation of the heart disease state that they're in. And I said, and people ask me, why do I say person dot this, and I say, well, there could be heart disease in dogs and heart disease in persons. And, if you talk with Lynn Weber, she's interested in heart disease in dogs. I'm interested in heart disease mostly in people. And so we have these different designations. But this is shared for all people. Their designation for heart disease is in common between all people. It's not specific to a specific person. Each person doesn't have a different definition of heart disease. It's heart disease, the designation of this state, or for that matter, of never smoker, current smoker, is in common to all people. Okay. Okay. Right. So when we have these things like we call uniform, for a while it has a variable called a formal parameter argument for the thing we passed it. When it returns, that's gone. If you have a person, they have variables within them, and when they die, those things are gone. So things only last for a certain amount of time. Not all variables are forever, okay? And most variables are not. Okay. Right. Yeah. I don't know how much I have to dwell on these things. These are, if anyone wants to look at these more, you can. You will sometimes see this. This is pretty common to see. This means make A 1 bigger than its current value. So it completely, as we say, desugars into A equals A plus 1. That's what that means. A equals A plus 1. Unless you have something around it that tries to use it, it's good enough to just say A equals A plus 1. If that's all you do, A plus plus, semicolon, you could just completely replace it with A equals A plus 1. But it's nice and terse because it doesn't force us to say A equals A plus 1 and read that whole thing. We could just say A plus plus. Make A 1 bigger than it is. Increment A is how we say it in computer science. Increment his age. And it will say, yes, ma'am. His age goes from 53 to 54. Boom, done. Okay? Alternatively, we can have expressions like this. Suppose we have A equals 3. If we write A times equals to 2, A will go from 3 to 6. This is completely equivalent to saying A equals A times 2. Indeed. If we have A divided equal to 3, it's A equals A divided by 3. Somewhere over here. A plus equals 2. A equals A plus 2. A minus equals 2 means A equals A minus 2. Why do we do that? Why do we do that? Why do we write it that way? Because, especially if A is a long name, sometimes you run across long names. You don't want to have to write it twice. You don't have to read it twice and say, is it the same name on the left and right, or is there one character off? You just say this thing times equals 2, and you know it's doubled. So when someone who sort of encounters code enough looks at that, and it doesn't take long, they say, oh, it just doubles it. It's just doubling it. That's all that means. Doubles it. This means it divides it by 3. This means it adds 2 to it. This means it subtracts 2 from it. Just glance at it, and I know that. Whatever it is, it does that. And I don't have, no fuss, no muss. I don't have to look at the left and right side to find if there's the same. I just say that. Okay? So you'll see this quite a bit. And you will even see it in code written by your instructor. And I have mixed feelings about it, but sometimes do it. Here's something where it's really long on the left-hand side. So long that my head is probably blocking it. So what is this thing doing? What's that big, long expression doing? Okay, besides scaring you, what else is it doing?
So it's getting the connected neighbor for the third person in the population, getting the income for the connected neighbor for the third person in the population,
that's right.
And then doubling it.
Yeah, so So it's actually not in the population, but yes, it's just about right. So it's getting the income of my third neighbor, and it's doubling it. Lucky neighbor, hey? So it's doubling. Oh. Okay, we can make this
I get
more.
it wrong. He throws the pen at me.
That's right. Yeah, that would be a neat way to run these sessions, but I don't know if anyone would come. Okay, pass the baton. Okay. Yeah, okay. Okay, ladies and gentlemen, I tried to emphasize this before, but suppose color referred to green. I was susceptible, and now I become infected, and it changes to red. The reference now points to red, but it didn't destroy the thing that it previously posted. It just is put to a different thing now. It's like if you were to, and I've got it's a hard thing to find a nice way of writing this. Let's suppose what's sort of a appropriate example for this. Let's suppose that that I have a car, and there's a title associated with the car, and I pass the title to someone else, so their name is on it now instead of my own. That doesn't destroy me. Even if it's, okay, I won't make a joke of it, but even if it's a very nice car, not destroy. But the point is, it doesn't destroy me. It's just, now my name is crossed out, their name is put there. That doesn't cause me to be, catastrophically killed. There'd be a lot less selling of cars if it did. So it is with references. That thing in the title is just a reference to me, and if it's crossed out and put a reference to someone else by name, that's fine. I'm unaffected, and so it is with these locations that hold values. So let's suppose that we have here a person who is associated with, they're 4 years old, there's no information on their mother, it's called null, and they are male, okay? By the way, I'm just putting in square brackets the type, it's not an array, it's just type. Now, associated with, I'm in Maine, so my this pointer points to Maine, that's me, points to Maine. And associated with Maine is a thing called population, which consists of references to each person in the population. And maybe I have a variable called M that refers to this particular person, who's female, has no recorded mother, mumble. Oh, I see. So is male is false. Okay, so they're female. Okay, fine. So suppose this is the case. Now, suppose we say A's mother equals M, okay? If we said that, now they refer to M. M still refers to this person, but A's mother also refers to this person. Now suppose we said A dot mother equals this. Now A's mother is still as this person. Man, this is a poor example. I'm surprised I came up with this. So now they refer to the third person in the population, 0, 1, 2. So here it is, 0, 1, 2. It's this person. Their mother is now pointed, but she's unaffected. She's unaffected. Gosh, this is really bad. Okay. So she's not been affected by the whole thing. It's just that the mother refers to this. Does that make sense? So just like with the title, we scratch out my name and put someone else's name. I'm not affected by it. By that scratching out of the name. It's just a reference to me. It's not actually me. Okay. Does that make sense? Okay. Java expressions. Java expressions. Java expressions compute values. Their job in life is to compute a value. Sometimes the value is a number. Sometimes it is a string, like we concatenate two strings. Sometimes it's a reference to an object, like a person, or like a dog, or like a deer. And by computing references, we can combine multiple such things and turn them into other things. And variables hold values. Their job in life is to hold value, and you can tell them over time, hold this value, hold a reference to this object. No, hold a reference to this one. That's fine. Or this value at some point, this variable at some point holds one thing, and then later it holds another. Okay. Values, ladies and gentlemen. Variables and expressions. Are we okay with that? Okay. Now, I need your guidance. I need